All right, so the last thing I want to introduce today is talking about polar covalent bonds. We've now covered the two extremes. One extreme is complete total electron sharing. If we have a perfectly covalent bond, we have perfect sharing. The other is electron transfer in terms of ionic bonds. So when we talk about a polar covalent bond, what we're now talking about is an unequal sharing of electrons between two atoms. So this is essentially something we've seen before, we just never formally talked about what we would call it. This is any time you have a bond forming between two nonmetals that have different electronegativities. So for example, hydrogen chloride, HCl. The electronegativity for hydrogen is 2.2. For chlorine, it's 3.2. And in general, what we say is we consider a difference in terms of a first approximation if the difference in electronegativity is more than 0.5. So this is on the Pauling electronegativity scale. So what we end up having is we sort of have a kind of, and what we call it is a partial negative charge on the chlorine and a partial positive charge on the hydrogen. The reason we have that is because the chlorine's more electronegative. It wants to pull more of that shared electron density to itself. If it has more electron density, it's going to have a little bit of a negative charge, and the hydrogen's going to be left with a little bit of a positive charge. So we can compare this, for example, to molecular hydrogen, where they're going to have that complete sharing. So this, there's not going to be a delta plus or a delta minus. Delta is going to be equal to 0 on each of the atoms. They are completely sharing their electrons. And we can also explain this in another way by talking about a dipole moment, where we have a charge distribution that results in this dipole, this electric dipole. And we talk about this using the term mu, which is a measurement of what the dipole is. A dipole is always written in terms of writing an arrow from the positive charge to the negative charge. In chemistry, we are always incredibly interested in what the electrons are doing, so we tend to pay attention to them in terms of arrows. Oh, the electrons are going over to the chlorine, so we're going to draw our arrow toward the chlorine atom. So we measure this here. So mu is equal to Q times R, the distance between the two. And Q, that charge, is just equal to the partial negative or the partial positive times the charge on the electron. So this is measured in Coulomb meters. You won't ever see a measurement of electronegativity in Coulomb meters. We tend to talk about it in terms of debye or 1D, or sometimes there's no units at all, so the D is just assumed. And it's because 1 debye is just equal to this very tiny number of Coulomb meters, and it's a lot easier to work with debyes here. So when we talk about polar molecules, we can actually extend our idea of talking about polar bonds to talking about polar molecules. So actually, let's start with that on Monday. So everyone have a great weekend.